So yeah, I'm going to be talking about some of the new hardware that Apple has coming up. You heard this iPhone 6s and 6s Plus are coming out. Two new iPads, MacBook and MacBook Air, da 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 da. And then I'm going to go through the Apple frameworks, some code, some demos, and then at the end I'm going to convince you again why you should really spend a lot of time learning SpriteKit before you go into SceneKit and Metal. And I'm not a metal expert. So, okay. About me, I do robotics, I do 3D stuff. I go to school, I worked for them. I'm the founder of a small game studio called Citrus Studios. One of my co-founders is here, Greg. Hey, Greg. We have 4 people, a code guy, an art person, a music person, and a project manager. We're very low budget and trying to launch our first game, Orbit, before the holidays, because that's when everyone spends money. And that's Orbit. He's adorable. This game uses SpriteKit, which as dependencies has UIKit, AppKit, depending iOS, OS X, and that includes core graphics, core animation, stuff like that. This is probably a review for a lot of you. We also use AV Foundation for our music and sound effects, and we use Gameplay Kit for our state machine handling. So is the game paused? What do you do? So this is the general gist of the talk. These are the 3 frameworks that we're looking at tonight. And you can pretty much summarize them with the things at the bottom. SpriteKit is for 2D, SceneKit for 3D, Metal is the low-level access to the GPU. That's the hard part. But it's not that hard. I convince you. This is stolen from an Apple presentation. Sort of helps you show how close to the bare metal each framework is. Bare metal meaning am I malloking and allocating memory? So here you can see metal is right next to the GPU. It's really low-level stuff. You're really flipping the zeros and ones here. SceneKit and SpriteKit, highly abstracted, a lot of fun to use. Does that make sense? Any questions? Okay. And this is a standard. OpenGL is a standard for 3D graphics. These are other Apple frameworks, core animation, core graphics, da 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 da. Can everyone hear me okay in the back? Yeah. Great. So, September 16th, iOS 9 got released. Who's got it? Who's got iOS 9 on their phones? Cool, you can play my game then. Along with it, Xcode 7 got released. So tonight we're going to be talking about some of the new iOS 9 features, some of the new Xcode 7 features. This is to perform. I feel like Dilbert, pointing at a positive graph. It's like an engineering tie. No. This is the performance increases in the new iPhones. The GPU is, I guess, 90% faster than, I don't say what, but I guess the iPhone 6. It's a really high number, very convincing. 360 times the GPU performance of the iPad Pro. That's the new giant iPad. What does that mean? That means that SpriteKit, SceneKit, and Metal are really attractive because all your users are going to have a great experience with your app because they have the hardware to support it. There's also some rumors about the new hardware coming for the MacBook Pro, MacBook Air. There's pretty much going to be 2 GPUs in that sucker. It's going to be a lot of fun, which might lead to a lot of iOS developers actually developing for OS X first, and then maybe iOS. All these frameworks now work on both. So you can develop for your Mac or your phone with the same code base and just a little bit of configuration. So that's actually a new thing here. So before I bored you to tears anymore, I'm going to show you just sort of a really simple app that I made using Model.io, which is part of Metal. Sizzle is a dating app for bacon lovers, if you're curious. So I recorded this a couple days ago. Sunset being dynamically generated in the background, reflections being dynamically generated on the ground, reflections on the glass being dynamically generated. This is all running on my iPhone. It's pretty impressive stuff. Model.io makes this a breeze. This is easy. So, this is the potential we're working with. So like I worked for a construction company. We did a lot of like 3D work for like buildings and skyscrapers. So this was like a test that we wanted to run and see if we could get Apple devices to work harder for us, which they can now. So it's pretty cool, right? Yeah. Thanks. So all right, let's start looking at some code. Enough of the high level stuff. Let's get to it. So this is, for anyone who's never seen SpriteKit, this is like the most basic SpriteKit Swift file you might have. This is like if you're making a game with SpriteKit, this is the structure of a level, what it would look like. So let's walk through this together. We import SpriteKit. Duh. Then we are subclassing SKScene with our level class. So every time we want to make a new level, we'll say new level. We'll talk about in our view controller, we would say present, level 1 or level 2 or something like that. You initialize it. Maybe you have some initializers up top. It comes with some parameters. So like it needs a size. Usually, maybe we would just say like the bounds of the view that the scene is within. So like, just make our SpriteKit scene as big as the screen. Duh. But sometimes you can also pass in other stuff where you see the 3 ellipse. Like say I wanted to pass a level number too. I'd do like level num : int. And every time I make a level, it asks for a size and the level number. And so I would give that to it. It depends on like what game you're, I don't know what you're making. Super init. So what that is saying is the SKScene class itself has an initializer and it requires the size. You give it to it, okay? It's like kind of a technicality. Some more variable stuff. Here at the bottom is the 2 important functions. Did move to view and update. So did to move to view, you initialize your game, right? And then update, every refresh of the game, the update function gets called. So if you're running at 60 frames per second, the update function gets called 60 times a second, right? Yeah. Yeah. So that's like intro to SpriteKit, Joe's crash course to SpriteKit. So like here's some of the old SpriteKit features before iOS 9. They're not even that old, so don't be ashamed if you don't know these. You can do shading, you can do shadows, you can do physics, you can do robotics, constraints, inverse kinematics, that's all robotics stuff. Field nodes. When I first started making my space game, I tried to program gravity in, and it was miserable, and it didn't work very well, and I hated myself. Then I found SK Field Node, and it did all the work for me. And all I had to do was like change a number and hit build again. Great. SK3D node, you can put 3D stuff in the 2D framework. Who knew? Xcode has some really cool built-in features like the texture atlas and the 2D scene editor, which I'm going to demo for you right now. So that is, let's talk about texture atlases first. A texture atlas is something you use to create an animation. Say you, in our game we have ships, and ships explode sometimes. So each frame of the ship exploding is like an animation frame. And SpriteKit deals with this idea of animations in something called texture atlases. So this is sort of like the default file structure of a texture atlas. I'm not going to like show you that. I'm not going to show you too much code because I don't have time. But like here is the image of a bear walking. So you can see like if I just click down through it, like the bear's legs are moving. All right. So you include this in your Xcode file, and there's some special code that you use with it. And it's super simple to just get an animation in your scene. Like, it's ridiculously simple. And then, actually, you know what? I will show you some code. Let's do it. Let's go straight to it. So here I'm making a class of an SK node, which is just like a default node type in SpriteKit. It doesn't have graphics. It just moves around left, right, up, down, big, small. And where does it get interesting? Bear images. So this let bear images SK texture atlas name is that too small? Can everyone see? Should I make it bigger? Okay. And that refers to over here we have a little. There's the bear images. There they are. See them? So this is how we do an animation. Now let's go to the level editor. So this is a level in my game. That's the character. He starts out here. There's a planet there, a planet there. This is what I call the objective. That's what you're trying to get to. And there's another planet here. They're different sizes. So let's go ahead and build that and see what happens. I think I already built it earlier. It should be pretty fast now. And I, you know, bear with me. It's not that good yet. I'm working on it. So yeah, the rocket is supposed to be at the butt of the rocket. Just give me a break. So, you know, like here's a spaceship. It's bouncing around. There are planets. There's gravity and stuff. The camera is rotating with the ship. Whoa, that's new in iOS 9. You couldn't do that before. So, you know, it's a pretty basic game right now. I can reset it. I can go back, whatever. But what I want to show you in particular is you saw this planet in the game. I bounced off of it. But check this out. I'm like talking backwards, so I feel like you can't hear me. But so, all right, let's put another planet in. Done. It's all right. It's a little too big. Let's make it smaller. It's still pretty big. Let's make it even smaller. Okay. So what I'm trying to show you is if you set up your code right, you can iterate and make new levels like insanely fast. So all I have to do is give this guy the correct label, which I just happen to know is Planet 1. Very descriptive. And now if I go ahead and hit build again, notice they're different sizes. Gravity, size affects mass affects gravity. There it is. It's giant, and the gravity is clearly stronger than the other planet. Cool. So we can use this built-in level editor in Xcode to not only position our stuff, but also like determine other properties like mass and gravity. Cool. That makes so like what's the larger context here? Why is that important? Because now if I just go back here to my orbit file system, I go to my levels, I can just dump out a ton of levels now, right? I can just make a ton of levels as long as I have all the assets and code in place. And then, you know, for those of you who aren't familiar, you have to go add files or and Okay. All right, so let's go back to the presentation. What am I at? I'm halfway through. All right, I gotta speed up, guys. Presenter view. So I showed you some old Xcode features there. You saw the camera node. It was rotating with the ship. That's a new iOS 9 feature, which I mentioned. There's also something called SK Audio Node. So I'm not going to show it to you, but if a fireball is flying by your character's head, it'll sound like it's flying by your character's head. Other cool stuff, more built-in Xcode features, the particle editor, which I'm going to show to you right now, and the live editor. That level editor I showed you, you can do animations in there too. So it's not just static. Like I can have something happen, and instead of making a level, make it a cutscene. So like maybe when you start, a new chapter, there's a cutscene. I can build those in the level editor. I don't have to program them. So let's look at the particle editor super fast. This is going to be really, really fast. So sorry if I miss. New, file, okay. And then you want to pick SpriteKit particle file or SceneKit particle file. Let's try a SpriteKit. Okay, fire is cool. All right, put it there. I don't care. Whoa! So I can make cool animations like fire in SpriteKit for free. I don't have to do this. It's there. And then how do I change it? I can add all these colors and stuff to it. So let's make the center of the fire white. Oh, cool, it's white now. That was easy. Okay, and let's make the particles, they last for 2.5 seconds right now. Let's up it to 6 seconds, right? I guess they last longer now. I can't really tell. Let's go for 500. All right, cool. So you can make fire, you can make glowing objects. There are a lot of cool animations that you used to go to Adobe Illustrator and make a gradient with a transparent background if you wanted something to glow, right? It was janky, it was hacky, it was not good. Built in. Let me show you one other cool thing. The angle range, if I pump this up to 360 or something, yeah. All right, cool. How am I doing? All right, 18 minutes. I got 12 minutes left. Let's talk more about SK Camera. How would you actually implement that in your code? Oh, there's a typo. It's supposed to be func, not fund. Pretty much, I want to show you how easy SpriteKit is. This is so easy, guys. Look, I make a new camera, okay? It's just empty. It's not doing anything. I make a hero, whatever my character is. I make some objects, an array of objects. Cool. When I move to the view, SK Scene has a built-in variable called camera. We just say, hey, camera, you're now my camera, which we made up above. And, add the hero into the game and attach my camera to the hero. So that's it. Now I've got a first-person shooter. I'm done. What else? And then, yeah, add your objects. Cool. That's how easy it is. I'm supposed to, oh, I did that demo already. Okay. SceneKit has, oh wait, that's, okay, I'm missing something, it's fine. SceneKit has that thing that we saw, the 2D level editor. SceneKit in 3D has the exact same thing in 3D. Awesome. I feel like I'm glossing over SceneKit. It's because I'm running out of time and there's a lot, and I want to show you guys other stuff. So let's set up a SceneKit scene. Remember how we set up a SpriteKit scene just a minute ago? Now we're setting up a SceneKit scene. So it looks almost identical, right? You have this did move to view thing, you have this update thing. The only difference is SceneKit doesn't have UIKit as a dependency, so we have to import it as well. Oh no. It's the exact same. So if you learn SpriteKit and get comfortable with SpriteKit, those skills translate to SceneKit like butter, smooth, right? So there's SpriteKit, there's SceneKit. SpriteKit, SceneKit, same thing. The only difference really is in the node hierarchy, and it's like very minute. In SpriteKit, you just say add a child. In SceneKit, because you're dealing with meshes and geometries and materials and stuff, there's like, it's a little bit different. You'll figure it out. So, all right, I want to do another demo with you guys for the newbies. All right, enough of that. All right, we're going to make a SpriteKit game from scratch. New, project, okay, game, great. Test. Okay, language, Swift, cool. Let's go with SceneKit, right? Everyone's done this before, right? Yeah, put it there. Okay. Oh, it already exists. Okay. All right, so I just made a brand new SceneKit game. Did you see any code? I didn't. So let's build it. For anyone who's never like used Xcode before, this is great. You just saw me build a game. It's kind of a lame game, but whatever. So this is Apple's default SceneKit game. Look how easy that was. So, and we're gonna look at the code in a second too. But like, look, I can move this thing around. It looks nice. It's got like shadows baked in. Cool. Let's get out of there. So let's go look at that code. Okay. They're setting up their scene, SK scene, and they're importing it directly from an art asset, their 3D ship model. Cool. They've got a camera. They're adding the camera to the scene. Okay. They move the camera, right? Cool. They add some light to the scene. Cool. Ambient light. Like, you guys can read this, right? I'm not the only one, right? I'm trying to show you that this stuff is more approachable than it seems. So, all right, that was SpriteKit and SpriteKit and SceneKit at a really fast. Now let's talk about Metal. What is Metal? Earlier we saw that SpriteKit and SceneKit are these really highly abstracted frameworks. Metal is not. It's really low level. It's right next to the GPU. Whatever like custom graphics you're making, like this is the key. This is the future. So if you want a really good job, you could learn Metal. It was designed for the A7 Intel chip. We're now almost at the A9 and A9X series. That should tell you something. Let's watch a little demo video of what Metal. One of my favorite parts about the open source software community is that you can message someone on Twitter who's interested in the same thing as you, and they'll respond. So I got in touch with who was doing a lot of cool stuff with Metal during the beta. And I asked him if I could play his video today, and he said, okay. Okay, so this is a live filtering of a Tai Chi video. And this is like a Metal thing that he made, okay? So millions of particles, lots of calculations, live filtering. So he's like pointing his iPad at a computer screen. Filtering is happening. in real time. This is the power of a GPU. You can see them, right? It's pretty cool. There's like a million videos I could have shown you, but I picked this one because it's my favorite. Anyway. All right, I'm almost out of time. Let's rush through the rest. Model.io is like a subset of Metal. It's like if we look here, see Metal Kit. So you can import Metal or you can import Metal Kit. Model.io is part of Metal Kit. So that's what let me do the 3D thing. Model.io lets you import and export STL files. So I was explaining this to someone earlier, but say we wanted to make an app that imports a 3D printed part and then exports the same part with some sort of pattern on the outside. We can do that on an iOS device with Metal, Model.io. It's pretty neat. I haven't written it yet, but so this is how I built that thing that you saw, the building. This is pretty much it. It's oversimplified, but that's really all it was. I got that building into a scene file, which is like the built-in SceneKit file type. Okay. I'm going to show you. I think I have another demo slide here. Of course I do. This is my last one, and then I'm done. So like this is that app, that video that you saw. This is the app behind it. And here you see art.scene assets. So my SceneKit assets, building.scene. There it is. So I can just this is an STL file that I got off the web, and I broke it up into 3 parts. This is from my construction side, but structure, facade, and then the crane was red, so I was like, all right, I'll separate the crane. But like you can see that like that dynamically generated sunset isn't there in the background, right? Only the ground and the building, and there's no sunset reflecting off the building. Yeah. So I mean, I pretty much did that, just like the code I showed you. That was it. There was no secret sauce. Stuff is very approachable. So I just loaded that scene right up. Cool. There's some other frameworks in iOS 9 that I'm just going to run through real quick. Gameplay Kit. It has built-in pathfinding, built-in state machines. So that's like if you pause your game, if you get a phone call during your game, if you, I don't know. Artificial intelligence is built in there. The Game Center got improved, and there's also something called Replay Kit, which lets you take videos of your gameplay really easily. Anyway, in conclusion, my experience with all this stuff has been that I found it easier to do SpriteKit, SceneKit, Metal in that order, rather than just trying to learn Metal right away. So that's what I'm trying to convince you of, that somehow my path was the right path. I hope you believe me. So like, let's just take a quick look at the subclasses of sknode. This is the basic type of SpriteKit. There's like, you can do so much with SpriteKit. So I say start small with SpriteKit. You're not starting small. You have to learn all this. That's crazy. This stuff isn't just for iOS. It's for OS X too. We should be seeing a lot more OS X apps. What's happening with tvOS and watchOS, I have no idea. Should be pretty interesting. I don't know how all this graphics stuff plugs into that, you know? Like, what's going to happen there? So, yeah. Start developing for the GPU with Metal. It's a really good time. Look at those big numbers. There's a bunch of new hardware. El Capitan is coming out at the end of the month. And finally, some myths. SpriteKit and SceneKit are not just for games. You can do them for simulations, use them for simulations, for robotics control, for live filtering. There's a lot more than just games you can do with these things. You You can use them in your existing apps to make the buttons pop. Small things like that. Metal is too hard. Yeah, it is really hard, but it's not too hard. And you can learn it. I believe in you. And the final myth is that games are easy to make. They're not. All right, that's it for me. Any questions, guys? Anyone? James?
How would you use SceneKit for robotics? Could you elaborate on that a little bit?
Yeah, that's a great question. We do robotic simulation in 3D environments. SceneKit being 3D, we could like create like long cylinder linkage members and set up like constraints between them. And maybe we have to write some of our own robotics code to make it work. But the idea is, as long as you have a 3D graphics environment, you can do robotics in it.
If you're writing a game in SceneKit or SpriteKit, can you also integrate Metal to some extent?
Yes. Metal has built-in support for these. You can actually write shaders for SpriteKit. So shaders, who knows what a shader is? Yeah, shaders are like the holy grail of GPU programming, right? They give you the most control, but they're also the most complex. Metal is built in to support SceneKit and SpriteKit, is what I should say. Other questions? Yeah.
What's the AI capability to have built into?
So you can like set goals. I'm like, there's like an hour-long Apple presentation, but my understanding is like you can have an agent and he has goals, and pretty much it's like a min-max function. I want to maximize this goal. So like, for example, if I'm a character in a game and my goal is to get to the exit, I want to minimize the travel distance. So in this way, you can set up AI, I guess. Other questions? All right, thanks, guys.